Yeah, welcome back everybody. Let's continue with the questions. And the next one is number 6. Two boats A and B left a port C at the same time on different routes. B traveled on a bearing of 150 degrees and A traveled on the north side of B. When A had traveled 8 kilometers and B had traveled 10 kilometers, the distance between the two boats was found to be 12 kilometers. Calculate the bearing of A's route from C. That's a quiet question and it's quite simple. It simply means find the bearing of A from C. So let's go to it. Number 6. Two boats A and B left a port C. Let this be port C. Let this be port C. Left a port C. B traveled on a bearing of 150 degrees. That's going to be somewhere around there. Let that be 150 degrees. And let this be B. Let that be B. That's B. This is port C that they both left, and this is B. Now, on a bearing of 150 degrees, this is 150 degrees. That's the angle. A traveled and B traveled on a bearing of 150 degrees and A traveled on the north side of B. That simply means A is somewhere around there, just somewhere above B. It doesn't mean due north of B. Due north of B is this, directly up. But that's not what it means. It only means somewhere above B. That's on the north side of B. So A will be somewhere around here. A will be somewhere around here, just above B. Now they said when A had traveled 8 kilometers and B had traveled 10 kilometers, the distance between the two boats was found to be 12 kilometers. So A traveled 8 kilometers. That's going to be, let's put that there. This is A, and it traveled 8 kilometers from C, and B traveled 10 kilometers. When A had traveled 8 kilometers and B had traveled 10 kilometers, the distance between the two boats, which is distance AB, was found to be 12 kilometers. So that means this is 12 kilometers. Now the question is, calculate the bearing of A's route from C. That means I'm finding this angle. We have said that the bearing of A from C is the angle from the north pole at C to the line that joins C to A. So that's the bearing of A from C. Now how do we find that? If I know this angle, let me call it theta. If I know this angle, then the bearing of A from C is going to be 150, which is the whole of this, minus theta. And that's it. That's how we'll get the bearing of A's route from C. Now let's go to that. I want to use cosine rule. 12 squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cos theta. Now I want to make cos theta the subject. That simply means 2 times 8 times 10 times cos theta equals 8 squared plus 10 squared minus 12 squared. If I bring minus 2 times 8 times cos theta, 2 times 8 times 10 times cos theta to the left hand side, it becomes plus 2 times 8 times 10 times cos theta. And if I take 12 squared to the right hand side, it becomes minus 12 squared. So from here, cos theta is equal to 8 squared plus 10 squared minus 12 squared divided by 2 times 8 times 10. And that simply means, let's do that, 8 squared plus 10 squared minus 12 squared. That's 20 divided by, open bracket, 2 times 8 times 10. And that's 0.125. That simply means theta is the cos inverse of 0.125. Let's find the cos inverse of our answer. That's 82.819. So therefore, bearing of A's root from C equals 150 minus, of course this is what I'm doing. Let me copy this diagram and paste it down so that you can see it as we solve it. This is a diagram. The bearing of A's root from C is going to be the whole of this, which is 150 minus theta. So that's 150 minus theta, which is 82.819, and that's 150 minus 82.819. 150 minus 82.819, and that's 67.181 degrees. But they said we should leave our answer, leave angles and bearings correct to 1 decimal place. That is correct to 0.1 degree. So that means the bearing of A from C is approximately 67.2 degrees. And that's very, very simple. So we go to the next one and take this out. We go to the next one, which is number 7. A surveyor leaves our base camp and travels 42 kilometers on a bearing of 032 degrees. If they say 032, it means it starts from the north. She then drives 28 kilometers on a bearing of 154 degrees. How far is she then from her base camp, and what is her bearing from it? So we're finding the distance of her final position from where she started and the bearing of her final position from where she started. So let this be her base camp. Let me call it A. She traveled on a bearing of, how to move that down in it, on a bearing of 032 degrees, a distance 42 kilometers away. So if this is 32 degrees and the distance, and this is distance 32 degrees, and this is distance 42 kilometers away, that means she's here now. Let me call where she is now B. Let's call this point B. And from there she traveled on a bearing of, she then drives 28 kilometers on a bearing of 154 degrees. So from where she is, she drives 28 kilometers on a bearing of 154 degrees. 154 degrees is going to be somewhere around here. And I want to make this 28 kilometers. I just need to make sure that it's not as long as 42. It's a sketch. Now that's where she is now. I want to call this point C. Now the question is, the bearing of C from B is 154 degrees. That's it, 154 degrees. This angle is 154 degrees. That's the bearing of her final position from where she drove to the first time from A. She started from A and went to B, and then from B to C. Now the question is, how far is she then from her base camp, and what is her bearing from it? So that simply means, what is the distance AC and the bearing of C from A? First of all, let me find that distance. Let's call it small letter b. If this is 32 degrees, this will of course be 32 degrees too. Alternate angles. If this is 154 degrees, that means the remaining here will be 26 degrees, because the whole of this is 180 degrees. So that means the whole of this angle is 58 degrees. 58 degrees. Now, how do we find b? That's very, very simple. We can use cosine root 2. B squared equals 42 squared plus 28 squared minus 2 times 42 times 28 multiplied by the cosine of angle 58 degrees. And that simply means, let's do that. 42 squared plus 28 squared, that's equal to 2548 minus 2 times 42 times 28 times cos 58 degrees. And that's 1301.6, let me say 0.63, okay, 0.6299. So b is going to be the square root of that, 1301.6299. What's the square root of that answer? And that is 36.078, which is approximately, they said we should give length correct to 3 significant figures, and that's simply 36.1 kilometers. Therefore, his distance from where he started to his final position is 36.1 kilometers. Now we want to find the bearing of his final position, which is C, from where he started, from A. So we are finding the bearing of C from A, and that's this angle. The bearing of C from A is this angle. The angle from the North Pole at A to the line that joins A to C, that's the bearing. So if I know this angle, I want to call this theta. If I know theta, I'll just add it to 32 to get the bearing of C from A, because that will give me the whole of this. So now let's go to that. Let's find theta. I think I need to copy the diagram and paste it down so that we can see it as we work it out. Now this is the diagram. It's down here. Now I want to find the bearing of C from A. How do I do that? Or maybe I should reduce the size of the diagram so I can just paste it beside it. Let me just paste a tiny image here. Yeah, that we can keep moving and also use. Now, bearing of C from A, theta if I want to find theta, I can say B, I'm using sine rule to find theta. 28 over sine theta is the same as B over sine 58 degrees. Yeah, that's sine rule. I'm using the sine rule to find theta. 28 over sine theta equals B over sine 58 degrees, and I already know B. That simply means 28 over sine theta equals, what's B? 36.1. 36.1 over sine 58 degrees. And when I cross multiply, that simply means sine theta equals 28 times sine 58 degrees over 36.1. That's what you get when you make sine theta the subject after cross multiplying. So let's say that's 28 times sine 58 degrees, no? Yeah, divided by 36.1. And that's 0.6578. So theta is therefore the sine inverse of 0.6578. The sine inverse of, so let me find the sine inverse of that answer. And that's 41.1, let's say 41.13. Or let's say 41.13. Now, therefore, the bearing, what is a bearing from our base camp? So, our bearing from our base camp, the bearing of the surveyor from our base camp is equal to, this is it, we can see the diagram, bearing of the surveyor from our base camp, this is it. Our bearing from our base camp will be the whole of this. The whole of this. If I make this longer, the whole of this. And it is 32 plus theta. So that's our bearing from our base camp. The whole of this. The angle from the North Pole at our base camp, which is A, to the line that joins our base camp to our final position. And that's it. So that's equal to 32 plus theta. Theta is 41.13, which is equal to plus 32. And that's 73.13, which is approximately 73.1 degrees. Because they said we should give bearings and angles correct to 0.1 degrees. Yeah, correct to 0.1 degree. So that's it simply. Our bearing, the bearing of where she is, our final position from our base camp is 72.1 degrees. 73 rather, 0.1 degrees. And that's very correct, 73.1 degrees. Yeah, that's very correct. Now to the next one. Now to the next one, which is number 8. Two ships leave at the same time, leave port at the same time. One travels at 5 kilometers per hour on the bearing of 046 degrees. The other travels at 9 kilometers per hour on the bearing of 127 degrees. How far apart are the ships after 2 hours? That's supposed to be easy. Let this be the port they are traveling from. They are both traveling from. Two ships leave port at the same time. One travels at 5 kilometers per hour on the bearing of 046 degrees. That means in 1 hour, the first ship travels 5 kilometers, and in 2 hours it will travel 10 kilometers. So the first ship will be 10 kilometers away from where they started from. Let me call the port they are traveling from P. Now the first one travels on the bearing of 046 degrees. Let's say this is 46, and the distance of that ship from P will be 10 kilometers. Because it traveled 5 kilometers per hour. So in 2 hours, it would have traveled 10 kilometers. And its bearing from the port it traveled from is 046 degrees. Now, the other travels 9 kilometers per hour on the bearing of 127 degrees. The other ship, starting from the same port P, travels 9 kilometers per hour on a bearing of 127 degrees. So that one will be somewhere around there. This is 127. And 9 kilometers per hour will mean in 2 hours, 18 kilometers. I want to reduce the length of this one. Let me make this 10 and this 18. This is the second ship. It's 18 kilometers away from 18 kilometers away from the port the boat left. This is the first ship. This is the first ship, which is 10 kilometers away from the port they left. So let me call this the first ship Q and the second ship R. Now, what's the question? How far apart are the ships after 2 hours? How far would they be apart? That's just the distance, QR. The trick here is that you need to know that after 2 hours, the first ship will be 10 kilometers away from the port, and the second ship will be 18 kilometers away, because it traveled 9 kilometers every hour. So that's what you need to be able to find their distance apart. Now, so what do we do? If this is 46 degrees, then this will also be 46 degrees. Alternate angles. Now, what else? If this is, maybe I don't even need that. I don't think I need that angle. I don't think I need to do that. The whole of this is, what is the bearing of? The bearing of the second ship left on the bearing of 127 degrees. So that means this angle, let me put it here, this angle is 127 degrees. The whole of this angle. The bearing of the second ship from the port is 127 degrees. So that angle is 127 degrees. Still use, this angle, the bearing of a second ship from the port is 127 degrees. So this angle is 127 degrees. Now, how do I find their distance apart? I need to find this angle. Let me call this theta. So if this is 46 and the whole of this is 127, that means theta, which is this, is 127 minus 46, which means it is, I don't need to even label it, I can find it. This angle will be 127 minus 46, which is 127 minus 46 is what? When you are doing the calculation, you have to be very, very careful. 127 minus 46 is 81 degrees. And having found this, I can find their distance apart. Let me call it small p. So p squared, I need to move it up, so I'm copying the diagram. And I'll paste a tiny image of it here on the side. That's a tiny image of it. P squared will be equal to 18 squared plus 10 squared minus 2 times, I'll bring it down a little, minus 2 times 18 times 10 multiplied by the cosine of angle P, which is 81 degrees. The diagram looks tinier when I paste an image. It's a small image. I don't want to paste a big one so that we can still have enough space to write. This is a diagram. So just for clarity, P squared will be 18 squared plus 10 squared minus 2 times 18 times 10 multiplied by the cosine of angle P, which is 81 degrees. And that's it. Now, so that means that's equal to, let's do that here, 18 squared plus 10 squared. 18 squared plus 10 squared equals 424 minus 2 times 18 times 10 times cos 81 degrees. That's 367.684. So that means P equals the square root of that, square root of 367.684, which simply means, what's the square root of our answer? Root of our answer, and that's 19.175, which is approximately 19.2 kilometers. Therefore, the distance of the two ships, how far apart are the ships after 2 hours? Therefore, the ships are 19.2 kilometers apart after 2 hours. So that's it, very, very simply. And let's pause and come back in a few to continue. Thank you very much, and catch you in a bit.